Alright, today we're talking about exponential functions. Very first thing you need to take a note of is what an exponential function is. It's any function in the form y equals a times b to the x. A is going to be known as our initial population. It's always a non-zero number. And b is going to be known as our growth or decay factor. It's also always a non-zero number, but it's also not 1. So it has to be something other than 0 or 1. Also, b will be positive for everything we see. So these functions get used for populations, and you can be talking about population of animals or people. You could also be talking about populations of money or even radioactive isotopes. So we're going to see a lot of different things happening with these functions on the next lesson. On example 1, what we're going to do is we're going to evaluate the function for given domain values. So here we've been given the domain values 2, 3, and 4, which means I'm just going to plug those values in for x, as I'm doing right now. So y equals 5 squared would be my first domain value, putting a 2 in for x, and 5 squared is 25. And I'll go ahead and say that's my answer for x equals 2. Now I'll have to do it for x equals 3 by just putting a 3 in for x instead. So 5 to the third power, 5 times 5 times 5, that's 125. And then I'll do it for the fourth power, y equals 5 to the fourth power, so that's 625 for that answer. Now I'll go over here and do the same thing, even though it looks differently. It's the same idea where these are going to be your two domain values. I'll go in for n. Also, I really want to point out that while there was not an a value shown here, it was 1 times 5 to the x. So there was still an a value of 1 here. Here your a value is 4 and your b value is 3. So we'll be tripling every time on this next problem, and our initial population is 4. So let's go ahead and see how that works. So t of negative 3, first of all, would be putting in negative 3 in for n, like so. Now you can use your calculator and just type in 4 times 3 to the negative 3 and it'll spit out an answer, or you could do it by hand where you move 3 to the third to the denominator, and 3 to the third power is 27. So 4 over 27 is my first answer for a domain value of negative 3. I can also do that for 6, where I have 4 times 3 to the sixth power, and that's really easy to put into the calculator there. 3 times itself 6 times, and then multiply that by 4. You get 2,916 for this one. So here's our first word problem dealing with this, and it is a population of rabbits in this case, because 20 rabbits was my initial population. 20 is my a value. They are tripling, so that's the reason why my base is 3 every 6 months. So x will be the number of 6-month cycles. And so it's not just time, it's how many cycles have passed. So I'm going to make a note for myself really quick that x is the number of 6-month cycles. Now I'm ready to evaluate the function for f of 4, because there will be 4 6-month cycles over 2 years. So I got to be careful not to use how many years it is, and actually how many cycles have taken place. So 20 times 3 to the fourth is going to give me my answer. Now in my calculator I just type in 20 times 3 to the fourth to get my answer. And that is 1,620 after 2 years would be the rabbit's population. Alright, for this very last graphing problem, I'm really going to focus on graphing using the calculator, and I will talk about what's going on if you're having to do it by hand. So very first thing is just hit y equals on your calculator and type in 3 times 2 raised to the x power. Now I'm going to actually be able to go to my graph and see it. If it doesn't pop up like this, you can hit Zoom Standard. This will be good enough for most multiple choice problems. Just be able to see the image of the graph and then translate that onto your to which multiple choice option it is. Next thing I'm going to do though is talk about what particular points you could use to get your graph, and you can get that by hitting second, which is right here, table. And once you're there, you can actually see different points. You can arrow up and down to actually write those down. Now, how are these points made? It's really easy task of just, for instance, I'll do -3 really quick by hand. You type it in the function y equals 3 times 2 to the -3rd power, and then you'll just get answer kicked back out, which in this case would be 3 over 2 to the 3rd, which would be 3/8. And that's 3/8 is actually what .375 is as a fraction. So this is what they're doing each time to get these values in the y1 column. Now we'd be able to graph by doing it by hand and complete the problem that way. But I'm really wanting you to focus on using the calculator, since the NCFE for this course is a timed test. You really need to focus on actually getting everything done as quickly as you can with the calculator being used. Alright, thank you, and let me know your questions.